Okay, second lesson for the first day, 1, 2, solving equations. So now we're going to be using inverse operations to solve multi-step equations, starting with these two-step problems. So most of these problems require two things to be canceled out to solve for x or any variable, right? So here we see 3x plus 1 equals 10. So if you want the x by itself, the 3 and the 1 have to be eliminated, not the 10. You're always looking at the side where the variable is, okay? Doesn't matter if it's on the left side or on the right side. Wherever this is, the numbers with this need to go away so that the x can be by itself. So here, we're actually going to start with the 1. The inverse of adding 1 is subtracting 1. So we're going to subtract 1 from both sides. You're going to be left with 3x, 1's cancel out, equals 9. Next, that 3 is not adding, that 3 is multiplying. So the inverse of multiplying is dividing. So we divide both sides by 3. X equals 9 divided by 3, which is just, and that's your answer, 3. All right, so we're just going to do a couple more examples like this. All right, here we go. Starting with the minus 5. The inverse of minus 5 is adding 5. Cancels out. Add 5 to both sides. You're going to end up with x over 2 equals 12. Okay, now this you can treat as a fraction, or you can just do it as dividing by 2. What is the inverse of dividing? Multiplying. So you're going to multiply. What are you going to multiply by? 2. So don't put the 2 on the bottom. The 2 is just a regular 2 that's multiplying. It'll cancel it out. And it's also just a regular 2 that's multiplying on this side as well. Okay, the x is now by itself. 12 times 2 equals 24. That's it. Next. Here. All right, now, to solve this, we're going to do the same thing, inverse operations. Get rid of the adding 3. We're going to subtract 3 from both sides. 3's cancel out. You're going to be left with 3 over 4x equals 15. Now, here we have a fraction. To get rid of the fraction, we use the reciprocal, the opposite fraction, the flipped version of this fraction, which is 4/3. That would be 12 over 12. They cancel out, gone. And whatever you do to one side, you do to the other. So we're going to multiply that out. 15 times 4, 15 times 15, oh sorry, 15 plus 15 plus 15 plus 15, because you're multiplying it times 4 times. You get 60. 1 times 3 is 3, so you get 60 over 3. You simplify it. Always simplify your fractions. Your answer is 20. Okay, here it's a little different. When you have parentheses, there's something called the distributive property. And the distributive property is that the number outside the parentheses is multiplying the numbers inside, all the numbers inside. So we're going to do 4 times x, and we're going to do 4 times 6. They're going to both multiply by 4. You're going to get 4x minus 24 equals negative 8. You're not multiplying both sides by 4. Okay, you're not canceling it out. You're just combining the numbers on this side together. So this becomes your problem. Okay, now we can solve inverse operations. Get rid of the minus 24 by adding 24. Okay, we're going to get 4x, that's gone, equals 16. Now that 4 is multiplying, so we're going to divide both sides by 4. The 4's cancel out. You're going to get left with x equals 16 divided by 4 is 4, and that's your answer there. All right, now for the last ones. Let's talk about negatives and exponents. Let's talk about this one first. The first step is obvious. You can get rid of that 6. Subtract 6 from both sides. right? Now, you're going to be left with a negative y equals a minus 3 minus 6. Minus 3 minus 6 is going to be minus 9. The way you can treat negatives is, think about a negative is like you're going into debt. You owe $3 and then you owe another $6. How much do you owe in total? You owe $9. So debt is always in negatives. Now, you have a negative y though. The way we treat this is this negative y is really a negative 1. So we want to get rid of that negative 1 because this negative 1 is multiplying. So we're going to divide both sides by negative 1. This will cancel out the negative signs. Why do you want to do that? Because whenever you answer for your variable, that variable needs to be by itself, isolated, nothing else, not even a negative sign. So now you have negative 9 divided by negative 1. Now this is different from here. Right here we were combining it. Here we're dividing. When you divide a negative by a negative, you get a positive 9, and that's your answer. So be careful with your negatives. Practice with your negatives. Use your calculator. Okay, last one here. Going to get rid of this 12. The opposite of subtracting 12 is adding 12. Inverse operations to both sides. You get c squared equals 25. Okay, next. To get rid of the second power, the square, we use square roots. That'll cancel it out. Wherever you do one side, you also do to the other. So the z is going to be by itself because the square root and the square cancel each other out. And now you're looking for the square root of 25. Now some numbers don't have square roots. If the number doesn't have a square root, you can leave it inside the square root. But this number is a perfect square. So the square root of 25 is 5. You have to write the answer as a regular whole number. You have to take the square root of it. Some numbers you can't do that. Some numbers you can leave in the square root because they are irrational. So some irrational numbers are like the square root of 10. This is an irrational number. If you use this in your calculator, you're going to see a decimal, something like 3.16 dot, 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 dot. It goes on forever. That is an irrational number. Okay, you don't write that as your answer. You can leave it as a square root of 10. But a number like 16, you can take the square root of 16. That's just 4. That is a rational number. So this would be irrational. And this one is rational. And it has to do with, could you write it as a regular whole number or would it be a decimal that doesn't stop? If the decimal doesn't stop, another example is pi. Pi is irrational. Okay? And that's it.